Pre-calculus, pre-unit 1 notes. We're going to define a relation, input and output, domain and range, functions, and interval notation. A lot of this is just review, so it shouldn't seem very familiar to you. First, we're going to talk about relation, domain, and range. A relation is a correspondence between two sets or a set of ordered pairs. For example, given the relation, we want to state the domain and range. Recall that the domain is all possible x values of each of these ordered pairs. And because we don't have numbers in between, because this is not a function, we're not using function notation, that's why we're only going to list the x values that we see here in order from least to greatest with no repeating values. So if I were to do that, the lowest number that I have is this last number right here, -3. After that, we get the -1, then we have the 0, and then we have the 1, 2, and 3. So that would be the correct way to write it. And notice I use these braces right here that denotes the set that we are using. So then if I want to find the range, remember the range is all possible y values of the ordered pairs. So that would be all these coordinates. And the same thing, we want to write it in least to greatest with no repeats. So again, I would use my bracket as best as you can make that. And we're going to start off with the lowest number that we have for our y values. And the lowest number that we have is 1. So I start using 1. Then the next number would be 2. And notice I have a 2 here and I have a 2 here, but we only need to write it once. We don't need to write it twice in our set. And then 5 and 10. So that would be the range of our function. So next we have functions and functions notations. So the first thing we want to do is define what a function is. Recall that a function is for every input value, there is one and only one output value, which means that there are no repeating x values. So for example, it says in each set of ordered pairs, the first coordinate represents the input, the second coordinate represents the output. Explain why each set is or is not a function. So you are going to do these two sets on your own, and then we'll go over those in class. Then it says on a graph, we use the vertical line test to determine if it's a function. And because functions are used throughout mathematics, the function notation is convenient and shorthand to develop to make their use easier as we're analyzing these functions. So instead of using the y equal, of course, we're going to use this notation right here, which is f of x, which is, again, the function notation. So examples, it says, given f of x equals the square root of x squared plus 1, find the following. So you're going to do A through D on your own. For the next part 3, it says finding function values from a graph. Use these examples on page 5 and 8 to help you. That's from the old book, so don't worry about that. So take a moment to pause the video and see if you can answer these questions on your own, and then unpause it to see the solution. So for the first one, A, it says find f of 3. Well, of course, we know that 3 is the input value or the x value. So if x is the input of 3, then we want to know what is the y value or the output value. So I have to go to my graph and find 3 in my graph, which is right here. The y value or the output value in this case is equal to 0. The next one says find the input whose output is 0. So you have to look for all the y values on the graph that have 0, which is the same one we just did, and here. So the input, of course, we know is the x value, so that would be an x value of -1, and also, of course, an x value of 3, because we just said that. Then it says find the y value that corresponds to an x value of 1. So again, I'm going to go to my graph. I'm going to look at the x value of 1, which would be here, and then right up there is the y value. So the y value of y is equal to 5. Also take a moment to see if you can find the domain and the range of this function in interval notation. If you are unsure, we're going to talk about that in just a second. All right, so inequalities and interval notation. We are going to be using the interval notation for the remainder of the school year. An interval is the set of all numbers lying between two fixed numbers. Note that numbers are in order from least to greatest as you're writing them. So when we denote them, we can use what we call parentheses or brackets. So brackets are going to include the number and parentheses are not including the number. So you just have to remember brackets include and parentheses are not included. So for this first graph, we see a number line and it's highlighted between C and D. And notice that C and D are closed circles, which means they are included in the values that we're using. Because they're included in the values and C is the lower value and D is the higher value on the number line, because it always goes from least to greatest, that's why we have this interval notation. So the way that we would write that would be bracket C, comma, D, bracket. So that denotes that we have all numbers or whatever it is in between C and D, including C and D. Now here in the next one, notice that they are open circles. Because these are open circles, we are not including C and D on our interval. So that's why we would use parentheses, C, comma, D, close parentheses. So again, that's this right here. For the next one, we have a closed and an open circle, so you can use a bracket and a parenthesis. So in this case, it would be bracket C to D parenthesis, and so on. So when we get down to number 5, notice that we have all values that are greater than or equal to B. So if this is B right here, and our arrow is going to the right, then notice that we would start with B because that's the lowest number that we can have, and we're including B, so it would be B, comma, and then infinity, and then parentheses. The reason we use parentheses for infinity is because infinity is not technically a number. So because infinity is not technically a number, you can't actually include it in your number set that you have. So for this one, the difference is instead of using a bracket, we have parentheses B to infinity. And then the next one are just going to negative infinity. And of course, negative infinity is lower than B in this case. That's why we have parentheses, negative infinity to B bracket. And the next one here would be negative infinity to B using a parenthesis, because again, it's an open circle. We're not including B. And negative infinity to negative infinity denotes the entire number line. So that's why this whole number line here is shaded. So if we want to use the answer of all real numbers, again, we use negative infinity to infinity. So here are 2 examples that we have. It says, rewrite the inequalities in interval notation. So this one, if it helps you to actually write a number line, I suggest going ahead and doing that. So if we have a number line here, we have 15 on our number line. It's a closed circle because it's x is greater than or equal to 15. And then, of course, greater than or equal to means we're going to the right because those are numbers bigger than 15. So notice it's a closed circle, so that's why we have bracket 15 to infinity. So for the next one, if we do the same thing and draw our number line, we have -7 and then 6. -7 is lower than 6, why it's first. -7 is a closed circle because it's equal to. 6 is an open circle, and it says we have all x values in between. So then our interval would be, should actually be written, that's not correct right here. So this should be bracket -7 to 6 parentheses. So this is wrong. I'll make sure to it's fixed on your sheet. So then for these next ones, I want you guys to do the interval notation on your own. So you guys are going to do these next problems. And also, of course, see if you can answer all these questions that I have just highlighted from here to here. And then for the next part, it says use interval notation to find the domain. So this is what we were talking about in the last one. Remember, the domain is all possible x values. So your x values go this way on your graph. So notice if we were to look at this graph, it looks like we're going from -1, 2, 3, 4. So this is -4. And it's going all the way to 4. Because that's this point right here is an x value that's the highest and lowest. Be careful though, because we have an open circle right here. So because of that open circle, that is at a value of 2, I would have an open circle here. This is a closed circle, and this is a closed circle. So if I want to write the interval notation for the domain here, I have bracket -4 to 2 parenthesis union. Union just means we have both of these sets together. Parenthesis 2 to 4 bracket. And that would be my domain for this graph. Again, it's all possible x values that we have. Then the next part we're looking at is the range of the graph. Remember, the range is possible y value, so you want to go from the lowest y value to the highest y value. So it looks like the lowest y value is a y value of -3, which is right here, and it's including, so closed circle. And the highest y value looks like it is 4. Again, it's a closed circle. And then if you look here, there's an open circle, we know, at this y value right here. However, that y value of 1 is taken care of here, here, and here, so we don't actually have to include it as we did for the x's, because there was no other x with a value of 2 on our graph, but on our graph, we do have other y values that we're using, so we don't need to put an open circle there. So that means that our range is going to be including bracket -3, 2, 4, and then bracket. So maybe go back to the problem with the graph in the last one and see if you can now answer it. So here's the problem that we have, and again, we want to find the domain and range. So again, the domain is your possible x values, which would be from here to here. It looks like the lowest possible x value for this graph is also -4, and the highest possible x value goes to 5. Again, be careful of that open circle right there at an x value of 2. There's nowhere else on my graph that it's defined. If there was a closed circle here, then we wouldn't have to put an open circle at 2, but because this closed circle is not there, we do need an open circle, and these are, again, closed circles. So if I want to write the domain of this graph, we know it's going to be bracket -4 to 2 parenthesis union parenthesis 2 to 5, and then bracket. And then, of course, as we said before, the range is the possible y values on the graph. So if I look at the possible y values on the graph, that goes from here to here, and the lowest y value that we have looks like it's at -3, and the highest is at 5. And again, we have a closed circle here at a y value 4. However, this right here is defined at a y value 4, so we can include it because there is a point on the graph that includes that 4. So that means that our range is from bracket -3 to 5 bracket. And of course, we'll be doing some more practice of this, but this is stuff that you did in Math 2 and also in Math 3. So again, just make sure you finish those problems that we did not do, and we will look at those in class.